Howdy, AP PreCal. It is Miss Kosh. At this point, I want to work through some of the polynomial stuff that shows up a little bit later. The sequencing in AP doesn't quite make as much sense to me, so I like to throw the division and binomial expansion in when we do polynomials. We have not done rational functions yet. If that doesn't make sense to you, then just keep listening, because here we go. Anyway, here we go. So the polynomial, if the polynomial f is divided by the polynomial g, then f can be written as f is equal to g of x times q of x plus r of x. Okay, so basically, let me get a scratch piece of paper. Basically what we're saying is if I take some polynomial f and divide it by some polynomial g, what I'm going to get is I'm going to get a polynomial q, but I may have q of x, but I may have a remainder. So now if you think about this for a second, let's say, I'm going to make the remainder part in just a second. I'm leaving this blank on purpose for a moment. Say we take 53 and divide it by 2. Okay, 2 goes into 5, and I'm doing this on purpose. 2 goes into 5 2 times. 2 times 2 is 4. Subtract that away, we get a 1, we have a 13. 2 goes into 13 6 times. We multiply that, we have 12. We subtract, and we have a remainder of 1. Well, what do we do with that 1? We take that, and we have, and we add it to that 26 that came before, and we take that 1, we divide it by 2. Okay, so if we have a remainder and we write it out this way, what we're going to do with that remainder is it's being divided by what we divided by here in the beginning. Okay, so hopefully that makes sense. If I take a polynomial and divide it by another polynomial, I can write it as a third polynomial plus the remainder over what we were dividing by. I'm going to use this again in just a second. I'll pull this paper back. But what we find is that AP doesn't use that notation a ton. What AP does is they write it out this way. So if I came along, if I decided I don't like this format, I'm going to keep this intact here for a second, but what I had is f of x is being divided by g of x, and we said that it was equal to q of x plus r of, that's an r, pretend, over g of x. If I came along and multiplied everybody, both sides, by g of x, these cancel right here, leaving me with just f of x. I have q of x times g of x. The way that AP likes to write it is they like to write g of x and then q of x next. And then notice these would cancel here, and I'm left with just plus r of x. And so what we will find, like if you think of this as our number example, if I have 53 divided by 2, this is equal to 26 plus 1 over 2. If we just think in terms of using numbers. I'll use polynomials in just a second. But this is not what they like to write in AP. They like to write out this expression right here. But basically where this is coming from is if we divide and get something plus a remainder over what we were dividing by, if I multiply through by g, then I get this equation, and that's what they like us to work with. Hopefully that was clear. Okay, so if the polynomial f is divided by the polynomial g, then f can be rewritten as f of x is equal to g of x times q of x plus r of x, where q of x is the quotient, r is the remainder, and the degree of r is less than the degree of g. Okay, so now let's look at an actual problem. Hopefully I gave myself enough space. You know what? I may not have. More scratch paper. Okay, so what I'm going to do, they're telling me here's f, here's g. They want us to write it in this form. So I'm going to come along and take f, which is 2x to the 4th plus, by the way, every time I go to divide, I look to see if there's any missing terms. They're not missing per se, but like if I had a gap, I'd need to say that there were 0 x cubes. Like if my original problem, maybe I should have written one like that. But if I had an x to the 4th and then an x squared but no x cubed, I need to put 0 x cubes. Okay, and we're going to divide by 2x squared plus 3. So when I go to do long division with polynomials, we take the first term divided by this first term here. 2x to the fourth divided by 2x squared gives me x squared. I like to be very intentional. I like to keep this column all of my x squareds. So even the answer at the top. Now, are you wrong if you write it over here? No, but I think that it's nice to stay organized. Okay, so then I'm going to take this and multiply back. This becomes 2x to the fourth plus 3x squared. Now, when we divided, if you remember, when we did this little division problem here, we multiplied 2 times 4, we wrote down a 4, we subtracted, we got this, and then we brought down the next value. It's exactly the same thing we're doing here. So I subtract, or change the sign, and this is gone. And if this is not gone, then I messed up. And then I have a 10x cubed, and I have a minus 2x squared, and let's bring down the next term is plus 15x. 10x cubed divided by 2x squared is going to give me a positive 5x. Here's my x column. So 5x, that gives me a 10x cubed, and then plus a 15x. Subtract, that's gone. This is not. Negative 2x squared minus 3 is what we have left. Notice, well, a negative 2x squared divided by a positive 2x squared gives me a negative 1. What I notice is that when I multiply by negative 1, we change the sign and they're gone. Okay, so this one didn't actually have a remainder. So we could say that this 2x to the fourth plus 10x to the third plus x squared plus, this is ridiculous, plus 50, I should have just written f of x divided by, what was I dividing by? 2x squared plus 3, that equals, well, x squared is right up here, x squared plus 5x minus 1. Okay, however, so what we did is we took this polynomial, we divided it by that, we get this, we have a remainder of 0. I did that on purpose. You'll notice in a second, I'm going to have you do a second one, which does not give you a remainder of 0. So I wanted both of them to happen, but they want us to write it in this form. So what are we doing? We have that our f of x is, well, let me write it another time because that was just so much fun, is equal to, the g of x that we multiplied by is this 2x squared plus 3. What did we end up getting as a final answer? We got x squared plus 5x minus 1. And then plus, you could say plus 0 if you want to. I don't think we have to, but it might be nice to indicate that there is a remainder of 0. Okay, let's look at the next one. I need more scratch paper. These just take some space. So anyway, so now I'm going to come along and do part B, which is we're going to take that polynomial. Where did it go? 2x to the fourth plus 10x. How many times do I get to write this? Apparently one more. Plus 15x minus 3. We're going to divide now right here by x squared minus x plus 4. Are we in focus? I think we're in focus. I hope we are. Sorry. When we do, we have, I'm taking this, dividing by that, I get 2x squared, and then I multiply back, and I'm getting 2x to the fourth. I don't think I've worked this yet, minus 2x to the third, and I get a positive, or if I have, I've slept multiple times. And my brother got married, so I am a little tired today. It was a great weekend, but you get a little tired after those big family events. Minus 7x squared plus 15x, I bring that down. Okay, so then 12x to the third divided by x, that's going to give me a positive 12x. Okay, multiply that back, I get a 12x to the third minus 12x squared plus, oh that's annoying, plus 48x. Who wrote this problem? Oh, I did. My bad. That's gone. This becomes a positive 5x squared. This becomes a negative, 33. How am I doing? 44, yeah, if I subtract, yes. Okay, bring down the minus 3. Okay, and then 5x squared divided by x squared is a positive 5. I multiply, I get 5x squared, I get minus 5x, I get plus 20. Subtract. That's gone. This now becomes a negative 28x and a negative 23. Okay, so what we're looking for here, this is now our remainder. And you'll notice what they pointed out here is that the degree was less than. The degree of my remainder had better be smaller than the degree of what I was dividing by. If it's not a remainder, and I can keep dividing. Okay, but what this means, let's see if I can fit this on. Can you see everything? Almost. Okay, this f of, I'm not going to write it again. I've written it too many times. F of x will be equal to, well, what did we divided the g value that they gave us. Is that what we do first? It doesn't really matter if you do g or q first. I'm just trying to stay consistent with what they told us. Here was the g. Q was what we found over here. And then we have plus a remainder of, well, negative 28x minus 23. You could factor out the negative and make it minus. I just didn't for whatever reason. If you write it in the other form, if you're trying to do, if you say f of x over g of x, what would that equal? Well, it would equal this 2x squared plus 12x plus 5 plus a negative 28x minus 23 over, what was I dividing by? X squared minus x plus 4. Where did I get that? Here's the remainder, it goes on top. Here's what I was dividing by, it goes on the denominator, and here's what we got as an answer. Okay, but this is not the format that I have seen AP use. I've seen this other one. Oh, you know what? I messed up. Oh, no, I didn't mess up. This was G is what I was dividing by. So this is part B, and this was part A. Okay. Okay, so what conclusions can we draw about the polynomial f when the remainder is 0? When the remainder is 0, that means that this was one of the factors of that polynomial. So it factored over that. This doesn't, like, if I wanted to keep going and solve this, it gives me, I mean, we can solve it, it's just gross, it's non-real. If I subtract 3 and divide by 2, now I take the square root of negative 3/2. I can do that, I don't know that I want to, but the point was that this is a factor of if the remainder is 0. All right, yep, I'm gonna make a slightly longer video. We'll do all the division in this one, and then I'll use, the next video is gonna be binomial expansion. It might take a couple videos, so let's finish this and then see what happens. There just are times when I lied. There are just times when synthetic division is helpful. So I'm just reminding those of you that saw this in the past. We write our coefficients down, and then we take, this is the factor, we take the 0. So the 0 would be a negative 5. I think one of these will work out nicely and the other one won't. I think that's how I designed this. But I bring this first number down, I multiply, so negative 20. Then I add. Oh, this is annoying. Negative 33, then I multiply. Oh. Okay, this one's not gonna be pretty. Okay, let's do this one. Can I blame it on the weekend, my brother's wedding? I'm very excited. I really like my sister-in-law. Okay, so here's this. Now we multiply we bring this down, we multiply 8. That gives me negative 5. We multiply, that gives me negative 10. That gives me 7 times 4. Ah, it did work out nicely. Okay, and that was synthetic division. So what we would find here is that our f of x would be equal to, which is right here, and I'm not going to write it this time, is equal to g of x times this, minus 5x plus 7, plus a remainder of 0, and I wrote the plus 0 to show you that I know that it has no remainder. Whatever we have here would be the remainder. I'm sorry, I'm just not feeling like multiplying and getting big numbers, so you can make me do this? What is this, 165? 30 times 5 is 150, and then plus 15, and it's positive. And then when I add this, that would be 72, 82, 182 times 5. I don't know, it just gets bigger. Somebody, first person to comment down below, what's the remainder on 3a? That'll be great. Okay, come back and see the next video. All right, we'll see you there. Like, subscribe, comment, all the things. Keep practicing.